Hi, in this video I'll be doing a feature walkthrough for the Caribou plugin for Grasshopper. Caribou is an OpenStreetMap importer. There's a few sort of similar plugins. What I hope to make in making Caribou was something that's a bit more compatible across Mac and Windows and different versions of Rhino, also a bit faster and has a number of features that were sort of more catered to some of the teaching I was doing, and hopefully those will be of interest to you as well. This is a sequel of sorts to an earlier video, a shorter video that was more of a general walkthrough of Caribou and sort of running through the basic workflow. In this video, I'll be walking through some of the features I didn't cover in that first video, as well as looking at how you can achieve a bunch of common tasks like baking or visualizing with color labels, and also how you can extend Caribou using standard Grasshopper components to sort of do other things as well. So in this video, I'll be walking through this file. It's called Caribou Extensions example. And this file is available for download on the Caribou documentation site. I'll link this below the video, but you can scroll down to where it says preview, baking, filtering, and so on. And then you can click to download this file. It might bring up a big bunch of text like this, in which case, if you want to save that file, you might need to, well, hit save and save it, but also importantly, change the file extension. So delete the .txt. If you're on Windows, save as all files. On Mac, you'd probably do a similar thing as well. So hit save, and then it should be in a format that Grasshopper can open. So you drag and drop it into Grasshopper to open it up. And when you do so, there's two things to note. The first thing is that this file path will be broken. As per the last video, you need to reference your own OpenStreetMap file or files in here in order to get data to load. So see the last video if you're not sure how to do that. And the other thing is that when you open this file, you may be prompted to install the human plugin. So we're going to use the human plugin to help us bake information sort of automatically from Caribou into Rhino with layers and colors and fun things like that. So you might, if you don't have that installed already, when you open the file, Rhino will probably prompt you to install it. Obviously go along with that, and you'll need to kind of shut down Grasshopper and Rhino completely across all copies and then open everything back up in order to sort of see these components here in the red. So I'm going to walk through this file. It's kind of color coded into blocks of similar functionality, and I'm going to walk through them one by one to kind of run through what's going on in each section. So up the top left here, this is basically what we did in the last video. It's the sort of basic workflow of we need a file, an OpenStreetMap file. We're specifying a bunch of features to extract from that file, which could be quite specific, or it could just be everything. And then we're extracting different types of geometry. So I'm extracting here ways, which are basically polylines, nodes, which are basically points, and then buildings, which are kind of polylines that have height data associated with them, which we can use to make three-dimensional extrusions. So in this case, or in this city, I'm still in Wellington. There's fewer, or sort of not all the buildings have height data. So we can sort of see that there are some, actually no, the building outlines aren't on, but you can see that there's lots of gaps here, right? So there's buildings which we aren't selecting, but hopefully in your city that you choose, there might be better data if you're just interested in 3D form. But okay, if we look at the data that we have here in Rhino, we can see it's got color. So this applies most obviously to the buildings, but also even if we zoom or look at the points, the nodes, or we look at the lines, which are the ways, you can see there's different colors going on there as well. And actually, if we zoom out even further, we can see there is a legend to our data, which is itself color-coded. So how do we do this? We're going to do so using the screen block here in Grasshopper. So this is just controlling the colors in terms of the Grasshopper preview, although when we get to baking, we can also bake them out with colors using the layer. But to run through how we sort of set these colors up, what we're going to work backwards from is this component, which is called the custom preview. So it's a standard Grasshopper component. As its inputs, it takes geometry and it takes material. If we make some panels, let's have a look at what those things look like. So in the first case, our geometry is a list of polyline curves. It's because we're dealing with ways. And our colors are a list of red, green, blue values. So those are the colors. If we wanted to visualize nodes, we would just basically connect the same block of information up to the same parameters. So the parameters we're using are ways, but we could equally use nodes, or we could use buildings. And then the other parameter we're using is the report. So this is probably a chance to talk about the way that these outputs are structured in terms of their list or tree structure, because that's key to understanding what's going on here, but also key to doing a lot of interesting things with this data in Grasshopper, kind of downstream of actually just extracting it from OpenStreetMap. So if we look at these two sets of data, so we have 6 colors, and then we have a whole bunch of polylines. If we look at the list structure on the left here, we can see that there's basically, there's a one level list or one level tree here. So each of these items have just one number, which represents their kind of list structure, and it's going from 0 through to 6. If we look at the items on the left here, we can see these also have one number going from top to bottom. So what we kind of end up with here is that we're ending up with our geometry organized into these different groups, and then those groups are what are matched up to particular colors. So from the perspective of the custom preview component, or the thing that's doing the coloring for us, we're giving it a list of items and then telling it basically which color is assigned to that particular list group or kind of collection of curves. So these items and their structure is coming from ways. So if we actually just go back to the source here, the component, what we see is actually a sort of two-dimensional list structure, or a list structure or a tree that actually has 2 items or has 2 layers to it. So these layers on the left, so the first number, the one on the left, they represent the features that we requested. So in this case, I've requested everything with craft, everything with emergency, everything with healthcare, highway, historic, and sport. So those are kind of the 6 categories that we requested. We can actually get them, you can look at them here. So 6 items labeled from 0 to 5. And so when we have the information coming out of the component, they're organized in that same sort of structure, where we have a 2-level list or 2-level tree, and the first level represents the category. So everything with 0 here is going to be coming or matched from that craft category. Everything with 1 here is going to be matched from that emergency category. And then in this case, or with this, with these geometries, in general, each item is going to be its own sort of list. So we have the second number, which is the one on the right, which goes 0, 1, 2, and then it starts again because we've gone up to the next category. So sometimes there are actually multiple items in these lists, but in general, it's going to be 1 item per list. So you can think of this as, okay, we're looking for the first category, and then this is the first thing we found for that category. This is the second thing we found for that category, and so on. So I'm mentioning this just to kind of explain a bit more of what's going on here, but also to talk about how Caribou works in general, because the way that we extract the color information for each of these categories is Caribou has a report output. And so this report output is also organized by category. So we have our sort of first category here, number 0, which is craft. And then we have a bunch of information about that category. We have a title, we have a kind of a key value sort of bit of text. We have the number of items found, and we have a color. And those colors are sort of generated by Caribou such that it tries to form a color palette that is relatively distinct. So you don't have 3 categories of information that are all 3 different shades of red. It's trying to kind of create colors that are sort of maximizing contrast. And it usually does an okay job. And then if we scroll down this list, we can see, okay, there's the next category and so on. So when we're assembling a list of colors, what we're doing is taking the list item component, we're looking for the 3rd indexed item, and we're just sort of plucking that out. So for each of these categories, we're just taking number 3. So this color, and then this color, and so on. And then what we're also doing is we're just kind of removing one of the tree level structures. So rather than having everything organized by individual item, we're just kind of flattening that out and having it only grouped by the category. And so that's all to say, when we visualize, or when we kind of get to this point where we're dealing with geometry and material, we have 2 lists that are structured in the same way. We have a list of lists of geometry bits. So, 3 polylines for this category, 5 polylines for the next category. And then we have a list of colors. And those 2 things are cross-referenced to give us a, visual display where each item, each bit of geometry has different colors. That works equally well for, ways, nodes, buildings. This is just the exact block that you can copy paste and put into your own definition. Moving on then, what I look at now is this kind of limeish green block, which is directly below, and that's what's generating this legend for us automatically. So the way that works is just using the legend component, which is a standard Grasshopper component, and working backwards from that, what this takes as inputs are a list of colors. And so the way we extract or get that color information is the same way we did earlier, where we're taking that report output, in this case from the nodes, and we're just extracting the 3rd item in each category or each list of information for each category. And that's giving us a list of colors. Maybe skipping to the bottom, the 3rd parameter for the legend is a rectangle, which is just the space in which to draw the legend. So we can reference a rectangle in from Rhino, or we can just right click, go set one rectangle, and draw wherever you want this to be. The middle parameter that we're taking is tags, which is essentially the text to display for each of the legend items. So we're doing the same thing here, where we're using list item to pluck out just an individual piece of information that's offered up in that report. We're taking the 0th item and the 2nd item, so the kind of the 1st item and the 3rd item, because Grasshopper starts counting from 0, like most computer things do. And then we're joining the bit of those 2 bits of text together. So if we look at what that looks like before it gets joined, we have a list of category titles, so craft, emergency, healthcare, and so on. And then we have a list of the number of things that are found, and then we're just joining them together with a comma. So if you wanted to, you could take any other piece of information that comes through from that report. Let's, put in like 5, which I think is the description, if that's not wrong. And that's the layer name, so it's going to look a bit weird, but we'll get to that in a second. Maybe we could put in this, which is the key. Well, that's going back to the description. Anyway, you can play around with the text there if it's going to be useful, or if you wanted to say just take the label, you could then obviously just sort of delete that 2nd item, so we just have the title. So As I mentioned before, Caribou tries to kind of create colors for each of your requested features that are sort of relatively unique. What you can also do, which is shown in this next block here, is just assign or create your own colors using the standard Grasshopper color swatch. So what I've done in this case is when it comes to visualizing the built geometry, because I'm asking for 3 categories here, I've just made 3 swatches, merged them all in. I had to graph that as well so it matches the list structure of the geometry. But essentially, that allows you to kind of create your own color palette if you find the Caribou one not particularly exciting. So that's probably something that might be useful to do as well. You might just need to kind of make sure that you're kind of always providing as many color swatches as you are asking for particular categories. So in this case, in the buildings, I'm asking for 3 categories and providing 3 corresponding colors. Okay, on to the red block. What the red block is doing here is actually, I'm just going to disable all of it and then re-enable it for reasons I'll get to in a second. But you can see when I re-enabled it, a bunch of layers popped into Rhino. So building, office, apartments, industrial. So, a parent layer and a series of children layers. And that probably actually would have happened automatically when you opened this file up. Although sometimes you might need to do what I just did and disable and then re-enable things, particularly if you're kind of changing around categories, because sometimes it'll just bake out the child layers without a parent layer. So if that's happening, just disable and enable things is probably the easiest way to go. But so the reason for making these layers is that we can automatically bake our information out, organized into those layers, and we do so by using the button that is called Bake. So I'm going to push the button, and then if I turn off the display for everything in Grasshopper, what I should be able to see here is that I still have a bunch of information, or in this case, a bunch of buildings that are organized here by their types. So we have these kind of industrial buildings, apartments, offices, and so on. I think actually the number of buildings in each thing is a bit wrong, but I'll fix that in the version that you'll download. So the way this works is we're, again, using these 2 human UI components. The first one is called Create or Modify Layers, which does what it says on the tin, where we're providing it a layer name and a layer and color. So we know how to get the layer color. That's using that same trick we did before. We were taking the 3rd item from the report. Similarly, you could substitute that with this method if you want to control the colors. What we're doing for the layer name is taking another item from this report, in which case we're taking the 5th item. And so the reason I'm calling this out here is that the 5th item is formatted in a way that's somewhat specialized. So in this case, with the building equals office, which is our 5th item, that's formatted in this kind of special way where it's set up so that the parent name is separated from the child name by this double colon. So that's kind of what gives us the structure in Rhino. We've got parent layer and then child layers. So that's kind of a special formatting that the Human UI plugin interprets and knows means kind of create this parent-child relationship between the layers. Whereas if you just put in a bit of text, just building, everything would kind of be on the same, would be only 1 layer deep. Then we're providing this list of layer paths to the create attributes component, and that's then giving us a list of layer attributes that are being assigned to each piece of geometry. So sort of in the same way we were using the colors as provided to the custom preview, here we're providing a list of layer names to the bake geometry component, which will dutifully bake things out when its parameter here is set to true, which is what the button is doing when we click it. Okay, I'm just going to delete all this and turn the Grasshopper preview back on, because what we're going to do next is look at this limey greeny block and see what it's doing. And so we're going to see what it's doing by zooming in on a building. Yeah, let's grab this one. And what we're going to actually first talk about is different types of metadata or information that is attached to geometry. And I don't think I mentioned this in the last video, but when we are using the specify features component, we're selecting from kind of a blessed set of information. These are sort of the major categories and subcategories as defined by OpenStreetMap. So they're called sort of features and sub-features. And they're kind of the, I guess, most important information, or perhaps the information that is most regularly used and sort of regularly structured, or at least it kind of forms this overview of all the stuff that OpenStreetMap has to offer. But then beyond these features and sub-features, there's also a whole bunch of other information that OpenStreetMaps provide. So if we look at this bit of text in Rhino here, we can see that there's this building equals apartment text, and that was one that we saw back in that big features list. So the sort of building is a feature, and the sort of apartments, or the the type of apartment in sort of typological sense, is a sub-feature. But then we also have all these other features which have slightly sort of weirder formatting. We have this address : city thing, which is the suburb this building is located in. We have a house number, we have a street name, we have the number of levels, and this number of levels is actually how we extrapolate the height of the building in most cases. And then this building also has a name. Maybe if we go for a zoom around, we can hopefully find maybe a slightly more interesting set of categories. Maybe the buildings that I'm working with here aren't particularly interesting. No, it's mostly just levels and names. But for example, you might find things like if it's a restaurant, it might list the type of restaurant it is. If it's a hotel, it might list whether it has Wi-Fi. Occasionally you just get like sort of random GIS data source references. In this case, this is a marked as a shop. It's got a name in terms of what kind of shop it is. Let's see if there's anything slightly more interesting around. Yeah, maybe not. So the reason I'm sort of highlighting this, or kind of looking at it, is that this is one of the outputs of each of these main Caribou components that we haven't really talked about, which is the tags output. So we talked about the sort of ways and nodes, or the sort of geometric outputs, and we talked about the report, which is kind of a kind of overview of each category. What we didn't talk about were the tags. And so if we just quickly drag these two panels up and look at them, the tags are what we're actually showing in the white off to the side there. So if I look over here, these are the list of tags. And so that's what we see over the side there. And importantly, these tags are organized with the same list structure that the actual geometry has. So in this case, we have these items which are tagged, or item number 00, so category 0, first item, and then we have tags over the side here which correspond, or they match. So these are the tags for this piece of geometry over here. Or if we maybe go down, this is the third item in that first category, and that's going to correspond to this curve. So there's a sort of cross-referencing here that we can do, because these are structured in the same way. And so going back to the lime green component, I'm not going to go into detail here about what's going on, but effectively we're taking as the inputs for this block, we're taking our geometry, and then we're taking our tags, And then we're using those tags to create a text tag, or actually a different type of tag, but we're using that to kind of render the text, which is the list of tags, in Rhino, in 3D, yeah. And everything that's going on in the middle here is just a way of, trying to display this information roughly oriented towards the actual shape. So you can see it's not doing a really good job about, pointing in the right direction or keeping the point particularly close. But you can improve on that or whatever. I think the value of this isn't necessarily, as a background for a render, but it's just as a way of being able to turn that information on and be able to kind of look around your site and get a sense of what kind of information OpenStreetMap has that isn't just the sort of features and sub-features that you filtered for or extracted from the get-go. Again, this is looking at that information relative to buildings. And if you're wanting to plug this into, say, the nodes component or the ways component, that will work. You might just need to change the logic for getting a point of information. So in the case of the buildings, we're using this brep closest point to kind of get a sort of south-facing point to draw the line to. If you're using a node, you can just connect this, directly over. You don't need that. If you're using a way, you might get the center point of the curve or the initial point of the curve through evaluating it. But yeah, that should be pretty easy to figure out. And that is what the lime green area is doing. Okay, going back, we're going to now talk a bit more about not just kind of visualizing the geometry that we're using, but we're going to talk more about kind of further filtering or extracting or understanding the kind of data that we're working with. So within the kind of workflow I showed last time, we start off by filtering the data before it even gets made into geometry. And that's using this feature and sub-feature method. What we're going to look at for the rest of this component, the kind of the dark blue and the sort of the tealish color, is filtering that information after we've made it into geometry. And so where I'm actually going to start off by looking at this or talking about how to do so is over here with this extract buildings component. And so one thing to notice in this case, maybe I'll just focus just on this, is that rather than using the specify features component, which we did earlier, what we're just using here is a series of text boxes, and they're just connected directly. So we have a text box here called building equals office. Maybe I'll just connect just that in, and then when that calculates, we can see, okay, these are all the office buildings. Similarly, I can drag in building equals apartment, and it'll finish, or it'll do the same job there as well. So when we're using that specify features component, all we're doing is defining these kind of special bits of text which are of this kind of key value format. So in the case of specify features, that's going to be key. That's going to be feature equals sub feature, or feature equals asterisk, which means basically just give me all the sub features or give me everything that has this tag. So going down here, rather than using that specify features thing and sort of finding building and then finding office as a subcategory, I could just write out building equals office. But what that also lets us do is use bits of information that aren't in the specify features window. So as I mentioned before, specify features kind of deals with these features, these kind of defined categories of information. But as I showed before with this, these kind of white bits of text, there's all this other information that is available in OpenStreetMap. So what we can do, for example, if we wanted to find all the buildings that have 3 levels, I can just take the text that I see here, replicate it as a text panel in Grasshopper, and connect that together. And then now this extract buildings component will show me all the buildings with 3 levels. So when this component here requests features, you can provide any combination or any sort of bit of information that OpenStreetMap holds. So for example, I could search for cuisine equals Mexican, which no buildings were found. And that's probably because there aren't enough, it's probably because the buildings that exist don't have 3D height information. So actually, if I'm searching for things in a really broad way, I would probably want to use the ways component. Maybe let's also use the nodes component as well, because I'm sure there are at least some Mexican restaurants. Okay, so if we look at nodes, these are all the Mexican restaurants that have data in Wellington. And that cuisine equals Mexican isn't a feature. It's kind of this extra bit of information that exists outside these main categories. And that's often where some of the most interesting, information comes from. So, okay, the reason I'm just talking through that is also to talk about a component that we didn't cover in the first sort of quick walkthrough video. And that component is the specify features component. Sorry, it's the filter tags component. And what that does is lets us kind of categorize or filter information after it's been extracted into geometry. So actually, I'm just going to close and reopen this file because I think I messed it up a little bit by messing with all the categories. But what we often want to do is filter or kind of check the data after we've already sort of imported it into geometry. And we want to do so basically by looking at what we found. So maybe I'll just go over to the left here and look at this component. If I'm going to create the Caribou component called filter tags and look at what it wants as inputs, it wants items and it wants tags. So the items are either the ways or the nodes or the building parameters. So I'm just let's connect all the ways here. And then the tags are just the tags there. So, it connects pretty easily. So once those are connected, I can click the filter tags button and it's going to bring up another window. And so this window is going to show me all the tags that are contained by all the items that this component is extracting. So again, we saw that as like a big list of information here. What this component is doing is taking all that list of information and then just sort of representing it to you in a nice sorted list. And so this is sort of the fire hose of all the things that OpenStreetMap is tracking. So there's things like different types of sidewalk, or whether the sidewalk is on the left side, the right side, or both. If we're looking at railways, that's not very interesting. If we're looking at, say, opening hours, we have different types of opening hours for different buildings. We have the one-way status of streets. We have different types of historic monument. We've got a horse category. There's no horses in whatever's going on here. Let's see what that is. So if I wanted to then look at all these items and then pick out just the ones that are tagged with horse equals no, which is, we can see in the description here, access permission for equestrians. So I'm going to look at all the information that is tagged with horse equals no. Cool, okay. So I can see some pathways here. So presumably all these pathways, horses are not allowed on. So that's an example of taking or finding interesting data from this kind of big fire hose of all the information that's provided. So maybe let's do something that's slightly more, slightly more pragmatic. Let's look for designated bus lanes. And sometimes, because this information is often machine generated or machine read, sometimes it's labeled in particularly strange ways. And maybe for fun, let's also look for all the buildings that are classified as having a brick material. So if we update that selection, okay, we've got some bus lanes going on. Presumably this building is the one with brick material. and so on. So this filtering tags becomes a way of, I think, both exploring the information that OpenStreetMap provides, but also, yeah, filtering it or kind of narrowing down these categories. And so what we can do is actually then take the outputs of a filter tags component and plug it into another filter tags component. So when we're specifying these filter tags, as I just showed before when I was looking for buildings that are brick and also bus lanes, those two categories aren't present, or probably aren't present in the same thing. When we're filtering, we're looking for any matches of either tag. But if we wanted to, for example, find combinations of tags, so if we wanted to look for like bus lanes that are dedicated and also have a cycleway, or sorry, rather roads that have a bus lane and also a cycleway, we can do that by sort of chaining together these components one after the other. So in this case, I have a filter tags component here. It's looking for streets that are identified as being one-way streets. And then based on the results of that, I'm doing two things. The first one is I'm refining that by looking for asphalt surfaces of the one-way streets. And then down the bottom here, I'm looking for paved surfaces. And then after that, I'm looking for cycleways of various kinds. So, at the end here, we can say that, okay, this street here is a cycleway with a paved surface that is one way. So we're sort of doing almost GIS style sort of combinations of filtering and sort of categorization. Below this, in the other blue component, is sort of a special case or a sort of an edge case. And that's when we're looking for categories or tags that have a sort of numeric output. So if we go back into this big filter list, many kinds of information are sort of have text-based values. So whether a building has a certain material or a bus is, or sort of busway exists or not. For types of information like building levels, that comes through as numbers. So it's, numeric numbers. How many levels does this building have? Another example of that would be one that's normally called maximum speed or max speed. So you can see here there's a list of different speed limits. So 5 to 100. So if we wanted to say just look at the streets that were like up at the upper end of that range, we could just tick those boxes and select them. Where that might not work or might be a bit laborious is if you don't know the range that you want ahead of time. So for example, if you were looking at probably building levels is a better example. If you wanted to find like all the mid-rise buildings between, I don't know, like 5 and sort of 15 stories, the one way you could do that without having to kind of go back through and tick these boxes once you've got the information is to use this block of components that allow you to kind of define a numeric range and just pick out values between these two limits. So in this case, I'm looking for streets, or looking rather for anything that has a maximum speed rating, and looking for, things that have a range between, I guess this is like 10 kilometers per hour and let's say, 25 kilometers per hour. So I'm kind of doing the same process of filtering by tag, but just doing it numerically rather than with a tick box. So if you want to use this, you just need to change the text here to be whatever kind of category you're looking for. And then maybe you might need to change the number ranges here to make sense for the kind of information you're looking for. I won't go into how these components work because it's sort of fiddly and annoying in terms of dealing with text and lists of text, and Grasshopper is kind of annoying, but basically it just sort of does a similar process as to what's going on inside this component here, where it's looking for matches within the list of tags that are provided. Okay, zooming out again and zooming in down the bottom, the last bit of functionality we'll look at here is the sort of light gray tealish blocks here. And this is another example of how you might begin to sort of filter or examine information or types of information based on the presence of that information or the absence of that information across different types of data. So sort of up the top here, we sort of looked at how we would sort of filter things one after the other, sort of in sequence or in parallel. Down the bottom here, we're sort of using a slightly different approach. We were looking for combinations of data. So in this first block here, it's dealing with simultaneous combinations of data, or rather combinations of data where they're both present. So what I mean by that is that the output we're getting here are all the items that are tagged with takeaway service and all the items that are tagged with wheelchair access. So this first point are all the points we found that have identified takeaway service. The second point are all the things or the points that are identified as having wheelchair access. And then through these components, we're looking at the overlap of those two categories. So things that have are tagged with takeaway service and also wheelchair accessibility. Down the bottom here, we're doing a similar thing, but we're looking for the presence of one piece of information as well as the absence of another piece of information. So our points here, these parameters, the first one is still all the takeaway, presumably restaurants, and the other one is all the things that are wheelchair accessible, which is everything. And we're looking for cases where something is tagged as having takeaway service, but not tagged as having wheelchair accessibility. So these are all the points that have takeaway service, but don't have wheelchair accessibility. And these are all the points that are tagged as having takeaway service and having wheelchair accessibility. And maybe this is a good time to probably note that, again, OpenStreetMap data is not necessarily comprehensive. So just because information doesn't exist doesn't mean that that corresponds with what is actually present on the ground. But yes, using this kind of not or and system is another way of kind of creating slightly more complex cases or slightly more complex ways of filtering the information down. The way each of these works is using a slightly obscure Grasshopper component called to do with sets. So in each case, we're taking these different point values, which could also be line values or buildings. We're making them into sets, and then we're looking, in this case, for the intersection of two sets. So basically looking for, here's two lists of data that are kind of uniquely identifiable, which in the case of the point is, basically its position in space. And then we're looking for cases where there are points that are present in both lists. So if it's present in the takeaway list and also the wheelchair accessibility list, then it must have both of those tags. So that gets us the output value. And then the rest of these components are just, they're trying to re-find the original metadata that was attached to each of these points. So as I mentioned before, this big list of tags has a defined structure, and that structure matches the list of geometries. And when we're plucking things out, or when we're finding these intersections within the set, that kind of messes with, or basically removes the list structure we had set up. And so it breaks the association between which bit of metadata is associated with each particular point. So we're using the member index thing here to find the original position of each of those points. And then we're using that original position to basically pluck out the metadata of that thing. So what we sort of end up with here is a list of points that have a list structure, or you could easily add a list structure in this case just by grafting it. But then we also have the metadata for each of those individual items as well. And so that means we could do further filtering of this kind of smaller set. But if all you want is the result, you can just, you can stop here and just use those components. For the case where we're looking for the not relationship, or the does have this thing but doesn't have the other thing, it's the same structure. We're just using the set difference component rather than the set intersection. So as per the sort of tooltip, the difference of two sets, i.e. the collection of objects present in A but not present in B. Okay, that's, I think, everything for this video here and for that definition. So I'll link to where you can download the file I walked through below, as well as to the Caribou documentation in general. This was recorded for version 0.13 of the plugin. I think things probably wouldn't change too much in terms of how it looks and how it works in the future. If it does, I'll update the comment below the video as well. Yeah, you can, the plugin is open source if you're interested to look at the code. Otherwise, hopefully you'll enjoy using it. Let me know if you have any problems with it, or feature requests and so on. There's a link in the documentation about how to sort of send all those comments over, although YouTube comments would be great as well. All right, thanks.